Okay, so let's talk about how we classify numbers in the fifth and sixth grade. So when we classify numbers, we use this type of Venn diagram right here that is called a nested Venn diagram. And that nested Venn diagram always kind of reminds me of the little Russian nesting dolls, where the smallest one fits inside a little bit bigger one, which fits inside a little bit bigger one, and it just keeps on going. So it kind of works the same way, to where this smallest circle right here is the most exclusive type of number. It has the most requirements on what can belong in there. But whatever belongs in this circle also belongs to this circle, and so on and so forth as you make your way. So our biggest circle up here is the most inclusive. It includes all of the type of numbers that we will talk about this year together. So I'm going to switch kind of back and forth between putting things in our Venn diagram and defining our different types of numbers. So let's start with our first type of number, the most exclusive type of number, which is called a natural number. Natural numbers get a nickname. They're also called counting numbers. And they're called counting numbers because they're simply the numbers that we count with. And when I start counting, if I were going to count, for example, how many circles I see, it would be weird if I started with 0, 1, 2, 3, right? We don't count starting with the number 0. We start counting with the number 1. So if I fill in my Venn diagram, this would be all of my natural numbers. Again, they're called our counting numbers. We start counting with the number 1. So this could include numbers like 2. It could include numbers like 400. It could include a number like 53 and 0 tenths. Okay, remember that 0 tenths right there is what we call an unnecessary 0, but they're going to try and trick us sometimes by putting that there. So just remember, if it's an unnecessary 0, you can get rid of it. Just pay attention to what number is there. They also might write a natural number that looks like this. Let's make it 15 over 5. They might put it in fraction form. Now, we know that this is an improper fraction, and we need to always simplify our improper fractions before we do anything. So I know that 15 divided by 5 would give me 3. So that was a natural number hidden by a fraction form. So again, natural number, it's the smallest type of number, the most exclusive type of number, also called counting numbers. Then when we move up to our next part of our Venn diagram, all of our natural numbers are also whole numbers. So a whole number is a number that is not negative, which means it has to be maybe positive, and it does not have a fractional part. Okay, now the reason I said that it maybe has to be positive is because there is one number that belongs in this whole number group that does not fit with our natural numbers, and that would be the number 0. Now, we've learned that 0 is not positive or negative. So it fits the criteria of not being a negative number and not having a fractional part. Now, 0 is the only whole number that is also not a natural number. So when I fill in my Venn diagram, and any type of Venn diagram that you see that classifies numbers, 0 should be the only thing that belongs in that whole number category, because everything else that is not negative and has a fractional part can be classified more specifically as a natural number. So again, everything that is a natural number is also called a whole number, but 0 is the only whole number that is not natural. Moving up to our next part of our Venn diagram, here we have integers, which we've been talking about a lot this week. So integers are the set of whole numbers and their opposites. So we know that our whole numbers, which are also our natural numbers, are all of our positive numbers or 0. So the opposite of a positive number would be a negative. So integers are just our positive and negative numbers. So when I fill in my Venn diagram, here are my integers. And the only thing that you're going to see in the integer bubble are whole negative numbers. okay? Because if it's not negative, it can be classified as a natural number. So this could be the number 18, negative 18, excuse me. This could be negative 20 over 4 because that simplifies just to be negative 5. This could be negative 21 and 0/10 because again, we've got that that unnecessary 0 that I can cover up right there. Okay. So again, every natural number is also a whole number. Every natural and whole number is also considered an integer, but not every integer is a whole number, right? We got to start on the inside and work our way to the outside. And last but not least, every single number that we talk about in the 5th and 6th grade is a rational number. Now, the way that I like to remember what a rational number is the word rational rhymes with fractional. So our rational numbers, if it's just a rational number and it can't be classified as anything else, it's because they have what we call a fractional part. So that could be numbers like 5 and 2/3, right? That 2/3 is the fractional part. It could be a number like negative 41 and 2/10. So again, that 2/10 is the fractional part. It could be something like negative 3/2, which simplifies to be negative 1 and 1/2. Again, I've got 1/2 as that fractional part. So now let's look at, if I give this a number, how can I classify it here? So I'm going to zoom in a little bit. So sorry for the pterodactyl. There it goes. Oop, too far. Okay, so the first number I'm going to start with is, it has these two weird lines around it, which we know those lines stand for absolute value. And we know that absolute value is the distance from 0, and it's always, always, always positive. So the absolute value of negative 8 is just the number 8. Okay. Now, this next column says, well, how do we write this as what looks like as A over B? So how do we write this as a fraction to fill in that definition of a rational number having a fractional part? This is how we prove that every number is a fractional part. So 8, when I look at it, is a whole number, and every whole number gets a denominator of 1. So that is how we write the absolute value of negative 8 as A over B. It's just 8 over 1. Now, when I look at the number 8, I always start in the very center. So I start by asking myself, is this a natural number? Can I count to the number 8? The answer is yes, I can count to the number 8. So that means it is a natural number. And because it is a natural number, it's also a whole number. And because it's a whole number, it's also an integer, and it's also a rational number. But the most specific is going to be our natural number right here. Our next one is 7/5, which is going to simplify to be 1 and 2/5. But written as A over B, that would still be 7/5. Now, when I look at 1 and 2/5, I notice, well, I can't count to 1 and 2/5. It's not a whole number. It's not an integer. And it has this fractional part right here, that 2/5. So that automatically just makes it only a rational number because it has that fractional part attached to it. Okay, I have negative 0 and 5/10, which as a fraction is written as negative 1/2. This whole number by itself is a fractional part. So if I see that fractional part, I automatically know it is only a rational number. Our next one, negative 3, can be written as negative 3 over 1. But negative 3, it's not a natural number because I can't count to negative 3. It's not a whole number because remember, the only whole number that's not natural is the number 0. But it is an integer because there's no fractional part and it's a negative number. So that would make it an integer. And because it's an integer, it's also a rational number. And then I have the number 0, which 0 written as a fraction would be 0 over 1 because 0 is a whole number. Remember, it's our only whole number that's not natural, so it fits this box right here. And because it's a whole number, it's also an integer, and it's also a rational number. Our next one, 17 and 0/10. That 0/10 is an unnecessary 0, so I'm going to get rid of it. So 17, I can rewrite it as 17 over 1. And I can count to the number 17. So that makes it a natural number. So it's also a whole number, it's also an integer, and a rational number. And last but not least, 1 and 1/2. If I was going to write this as A over B, I need to do the good old sixes, two-step to it. So 2 times 1 gives me 2, plus 1 more gives me 3 over 2. But because I see that fractional part there of 1/2, I automatically know it is just a rational number. Okay, so when I think about classifying numbers, I kind of like to also bring in a different example. And I love my Sonic, so I've got my Sonic cups here. So my small Sonic cup represents our natural or our counting numbers. My medium represents the whole numbers. My large represents our integers. And the root 44 represents our rational numbers. So how I like to think about this is, remember, we always want to start with the most exclusive, the smallest type of number, which is our natural number. And the next inclusive size would be our whole numbers. So natural numbers fit inside of our whole number cup, which means that every natural number is also a whole number. The next thing would be our integers. So when I put my whole numbers and my natural numbers inside of the cup, they all fit inside of our integer cup, which means every natural and every whole number is also considered to be an integer. And then when I put my integer cup inside of my rational numbers, they also all fit in there, which means every natural, every whole, and every integer is also a rational number. But if I tried to stick this rational cup inside of my natural numbers, it doesn't fit. It falls right out, which means that not every rational number is also considered a natural number. It doesn't fit. It doesn't work. Just like not every whole number is also a natural number. It doesn't, look at all that room sticking up right there. It doesn't fit. It doesn't work. But every natural number is considered a whole number. Okay, so that's one way to think about it too, is we want to start with the smallest, most exclusive, and keep going up as everything becomes a little bit more exclusive. Okay, so when we do our daily recap in class of how we classify numbers, I'm always going to start by saying, show me your natural numbers. We're going to start with our hands class together because that is the smallest, most exclusive type of number. So we're going to say natural numbers are also called counting numbers, and we start counting with the number 1. Then every natural number is also a whole number, but the only whole number that is not natural is the number 0. Then every natural number and whole number is also an integer. Integers are our set of whole numbers and their opposites. Then every natural number, whole number, and integer is also called a rational number, and rational rhymes with fractional.